We're going to hear from Siemens again now, but this time from a user/customer perspective, sort of a report from the field, if you like. And we have two guests for you now. The first studied mechanical engineering. He's responsible for over 140 robots, and he works in an international production network consisting of a total of 4 plants. Tasks also include planning and design of a new production site. The second introduced the first lightweight robots at his equipment plant back in 2016, and he is now responsible for automation implementation with his team. He knows the necessary steps and tasks that are required from design to programming to acceptance. From Siemens, please welcome Strategic Production Planner for Automation and Logistics, Matthias Ziegler, and Automation Specialist, Michael Brucksch. Welcome. Hi, it's great to have you here with us. Hi.
Hi.
Whom can I give this to?
That was Matthias.
You. Perfect.
Yeah, hello everybody. Yeah, so we have heard a lot of AI, of startups from robot vendors and so on. And this is our chance now to give some insights of our factories where we are working on. And yeah, we're quite happy to do this. So who are we? It's me, it's Matthias Ziegler. As already mentioned, I'm responsible for automation and logistics in our factory in Nuremberg, so in Upper Palatinate. And we are producing the PLCs for Siemens, so I think they are well known. We have heard a lot of, so S7-1500, ET200SP, the TIA portal, and so on. So this is stuff we are producing and doing in Nuremberg. And on my right side, Michael.
I'm Mike Brucksch. I'm working at GWE in Erlangen in our plant. We produce the Dynamics S120, and I'm responsible for the automation implementation. So we program the robots by ourselves. We bring it to our production lines. Also we do everything with the robots, with TIA portal, with PLC, with everything to automate our plant.
Yeah, thanks, Michael. Yeah, so today we want to give you some insights out of our factories. As I mentioned, we have heard a lot of different things, theoretical stuff, and to give you today some insights out of our factories, out of the practice. And if this would also come to you, then we will be really satisfied. So starting where we are coming from the past, going through the present, and in the end going to the future. Michael also will present something, what we will do in future, what we see on the upfront there. So when we look in the past, when I have a closer look in our different factories, then we see a lot of different robots. Of course, we use robots since years, since decades. So I think our first robots were introduced in the 90s in our factories. And when I look on our current map, how many robots we have in our factories, then we have heard 144 robots still only in our electronic works in Amberg we are using there. Our problem in the past was always so there are so many different robot vendors, and each robot vendor needs a specific expert who can program the robot. And also, we have different hard and software. We need different experts. We have different languages of the robot. So it was really difficult to handle this stuff in our factories. It also was difficult for our maintenance because we have different hard and software. And this makes it all really difficult. And in the end, also our machine integrators face the same problems. If we need a new machine for our facility, often we buy them from integrators. Then they face that we want to have on the one side a cooker robot, on the other side we want to have a Stolby robot, and always they need to change their what we as a customer want. And of course, as a customer we want often different things. So, and here you can see how many robots we have in our European factories. Here are 3 factories, so the Electronic Works in Amberg, in Fürth, and in Erlangen, so they are really close to here. But of course, you can imagine if we look at our plants in China or in Asia or in America, then there are much more robots than these 5 we can see here. So these are problems we faced in the past. So communication, as I mentioned, it was an expert necessary for each robot brand. You need experts on each shift. So we are working 3 shifts a day, so 24 hours, 6 days a week. It's really difficult to manage this. You need a lot of personnel there. Then we also faced the problem, we have this in Amberg, that we have in one machine different robot vendors. So it's also difficult not only for us as a planner or for the integrator, it's also important for the employees which are working at this line, because they of course, they have then 2 or 3 different teach panels there. So different languages they have to deal with. And also then job rotation and job sharing is really difficult, because maybe you have an expert for this line, but you can't use this expert for another line because he is only an expert for this line. So this is really difficult. And of course, in the end, it's also hard and it's a huge effort necessary to analyze and collect your robots' data. I think you all can imagine this, so you see it in your factories. This is always the same. And what we have done, I think we have heard a lot of about in the last robot get-together for robotics last year. And we have also heard a lot of in the roundtable before. So we still use Siemens robot library since now nearly 2 years. And it's not only one robot we use there. So we see the SRCI, the standard robot command interface, as a really standard which we rolled out in our factories, starting from Amberg, but also in Erlangen, in Fürth, and now we also want to roll out in China and so on in our other plants. So our big benefit we see it out of a perspective of the factory is that our employees, which are working at the line, that they are see an easier user interface, where they can handle different robots at the same time. It's much more easier for them. As I mentioned, if you use different robots in one line, it's really difficult. And of course, often it's like a border. So our employees do not want to use a teach panel because it's a robot. It's not a teach panel from Siemens. And of course, we are a Siemens factory and we want to use our own products. So if they see a Siemens panel, it's much more easier to go there to use it. And it's much more difficult in like a border to use an Stäubli panel, a KUKA panel, what else. Nothing against your product. So this is all fine. But we see this in our factories. And I think you have same things in your factories. So for a KUKA factory, I think for the employees, it's much more easier to use a KUKA interface because they know it. Yeah. And of course, we have since years Siemens panels at our machines, and Siemens PLCs in the machines. And in this line, you also have then a KUKA panel or an Yaskawa panel or what else. And now this is all brought together to one platform, to one tool. And so our employees love it. And also for the maintenance guys, you have one speech, one language you can use. So as I mentioned, we do this not only with one robot, we do this since the last 2 years. So in the last year only, we integrated 27 robots in our factory in Amberg. And of course, there are much more robots in our other factories. So this is really rolled out. And yeah, we can see this also in our pictures here. So from different vendors, as I mentioned, we buy often the machines from the integrators. And I took out one example here, an assembly line for our ED200SP PLC controller. Here we use Stäubli robots, which are assembly the product on this SuperTrack system from ATS. Yeah, and what we see on our side as a customer, so we are an end user, we are not the development part of Siemens who is developing the SRCI, we are the end user. So we see savings on the one hand in the engineering and the commissioning, but we also see savings in program changing. So of course we also change our programs during the lifetime of our products and of our machines. And of course, in the end, this gains productivity, which could be increased nearly by 15% only by using Semantic Robot Library as a standard tool for our factories. So this is what we have seen in the past and see in today what we are doing every day. But if you look a little bit in the future, we see not only SRCI, we see not only the Semantic Robot Library, I think we see much more. And I just want to tell you something about some different use cases. So here, for example, is a use case in Erlangen. It's about THT inserting. And what we see, it's more necessary than only programming. It's more about data which need to be gained and need to be produced and need to be collected together. So and especially for this, we see coming from the standard robot command interface, we often talk about programming the robots, but it's not only about programming by or manual programming. It's more about an automatic robot code generation, what we see upcoming. So we have heard a lot of different AI skills and so on. So of course we see it also in our factories. We think we need it. We have heard it in the roundtable before. Of course, we also will see standard traditional automation in the future. So the standard automation lines for mass production, I think we will have this always in the next 10 or 20 years. But what we also try to do is to automate more advanced applications. And THT inserting is one of this point. And what is necessary for it is use of cameras and sensors. So when you go maybe 20, 30 years back, then we had a hard-programmed robot, which is always doing the same things. But in future, there is more necessary, and especially for this THT inserting, you need maybe a force-guided application, a force-guided robot, because you need to get the whole, and maybe the PCB is not always the same. So you have the small problems which we see every day in our shop floor. So because the PCB is not every day the same. So sometimes it's different, and sometimes the PCB is changing, so the product is changing, and we need to adapt faster on these applications. And therefore, cameras and sensors will help us to get faster here. Another example could be our HMI production. So I think every one of you knows the HMIs, which are produced and used everywhere in the world. I think we also have one at our personal stuff here. And producing HMI means today often to insert also cables. Yeah. And cable, to assemble cable in a product automatically is a real difficult and high advanced application. And there we see, okay, this is not the thing we want to do every day and all the time, but we see it's necessary. So for some applications, it's still necessary to insert cables. Of course, we try to change our designs. That is not necessary anymore, but we see it, we have it. Also look to the car manufacturers. They also need to insert a lot of cables in the cars, and this is really a high advanced application where it's necessary to have more than only a robot. And last but not least, we're also talking about robot teaching and program optimization by reinforcement learning. So it's should not all done by us. It's more that a robot also can learn by doing. So we do some research projects together with the University of Munich to come further on here. So it's just an example what I want to bring here. For example, to assemble a simple product, as we have seen here on our assembly line for the E300SP, where you just bring together some blocks, some different housings and so on. And of course, today everything is programmed manually. And this is a point where we see, okay, it needs to go easier, to go more in an automatic way, that the robot is trying out things for himself and not is done manually anymore. So and therefore it's necessary to collect data, and what we are doing with the data. Michael will tell us a little bit more about it, where we see the future of data collecting and use of data.
Yeah, thank you, Matthias. Yeah, data is necessary. We all know the past. We are a high productivity area, Germany, and I'm sure everybody in his plants has lists where the employees make lines and then count and then say, oh, what is the problem? Then the expertise, when it's the problem, the technician comes, they discuss with the line workers and think, oh, what is the problem? Is it this? Is it this? Also in the past, yeah, or in many factories at the moment, we do it all by hand. Yeah. Then there are plants were using data. It's not rocket science. As data is a standard. I think every plant uses data. At the moment, the PLC grabs the data, grabs the information from a cell, from a line, stores it, bring it to a data system. The data normally analyzed manually. The worker, the employee is sitting and see the results from the line and say, oh, we have a problem, we have to do something to get better. And in some plants, there's a co-pilot like ChatGPT. I asked the co-pilot, is there a problem? Is there anything else? So these are all topics that we have at the moment. A picture of a board from us. You see how many parts we're producing, the cycle times, and so on. So this is standard at the moment. But what is the future? So why we have to program? Why have the programmer program collecting data, collecting informations from machine? When you think on a USB stick or on your headset and you put it into your PC, you don't write a driver or anything else. You connect it, then you wait, and then it's finished, and you can work with it. Why we have to program all these parts? I don't know it. And why, when we have data, why can the data system that says, hey, Techniken, I have a problem, and when I have a problem, this is the solution, please do this, and this works, or in the future too. So I call it future one, the near future, and future two. When the system knows I have a problem with the machine, I have problems, then why cannot a robot move another way or do anything else? Also, I think when we have all the data, all the information from the robot vendor, from all system cameras, force torque sensors, or anything else, we can use it. And we are trying to work with this information. I have a short video from our production line, from our production plant. We are in Erlangen, but not in our plant, but I can give you a picture, a video from our production line. So from my home office, I can connect me to my system. Then I see our plants in the world. I can check what plant that I want to see, or our management. It's for management topics necessary. Then we fly to our plant. This is our standard. Standard. Yes. Then we see the key facts from our plants. We have sustainability, waste, water, the information. Then we can click to line, and then we fly over our production. And this is not a video filmed by a drone. This is all simulated. So we see the robots are moving. We are grabbing the information from the robots, the program code, bring it to our simulation software, and then we make this video, but we want to use this information in real time in the future. We need the information, data, more data, desto more features. We see where lines are blocking to make the balancing of lines. And so more data, more features. The performance of the line, our HEVs are running. Also at the moment we can simulate everything. It's only begrenzt of the power of the computers. Yeah, then we see a robot, see the information of a robot. It's a special cell, but we fly to a little small cell, where it's easier to explain it. And at the moment, we have problem to getting the data, the informations. But when we're thinking on backups from the robot program code, at the moment, normally the robot program code is on the robot. With SCRI, we have it on the S7. We can make automatic backups and everything else. We see in our system with the information what are the problems. The information, temperature, force. I think there we have the current of the drivers. Here we have had a problem with the driver. So we can use every information from the system. And a really big feature for us technicians in the future is to move the robot or to make the time shift with the robot. So everybody knows, every technician knows, we have a problem at midnight in our facility, in our plant. And what was the problem? When we make time shift, like in video recorder, and play back what was done in the past. What was the problem? Where was the robot moving? What has the camera for informations? Then the technician knows better what was the problem and so on. And then with this information, we are sure to get better lines, more productivity, better systems. And then we fly back from our plant. Und, das brauchen wir nicht. Ja. So we see the topics data and the topics robot programming is really necessary for us.
Yeah. So as a short summary, what we have seen, on the one hand, we have our programming stuff, our programming tools, SRCI stuff, everything what we do on programming. On the one side, manual programming, on the other side, virtual, and then programming by AI, and then copilots and so on. On the other hand, we have our data. So we need to collect data. We need to get that data out of our machines. Our PLC connection helps us and so on, and the connection to the machines. And in the end, of course, we also need our machines. So it's not only software, it's also hardware. So of course, I think in Germany we have perfect machine builders and so on. But these three points have to work together and have to be brought together. And it needs to be brought together. We see there an industrial metaverse platform. So an example was shown by Michael, and this could be something where we see our future, that we more work on these platforms. I think we have a lot of heard about this platform, and I think this is a thought we should take to our future, because there we can match all the things. Many thanks for your audience.
Thank you, Michael. I think we can squeeze in one quick question, if there is one in the audience anywhere. Is there anything you would like to know from Matthias and Michael? Doesn't seem to be the case. Ah, yes, here at the front. Yeah. Jens.
All these recording to go back and forth on the timeline. So how much data do you record per... Sorry? So if you record all the data for time shifting, how much data do you expect to record per day?
Oh, it's a really interesting topic. We discussed the topic. It's not so easy when we have over 100 robots, and every robot sends his information to our data system. Also we have to connect one robot with the system and over gigabytes, but how many each day? I don't know it. This is topic from our software, but it's a big topic. The cost of the data, how long you want to save the data. It's a terrible topic.
I think, as you mentioned, it's not a completely new topic. So I think that we collect and gain data. This is we do this since years, but I think since a few months, since a few years, we have the processing units which can handle this huge amount of data.
Okay, thanks a lot. So some months ago, I was at a not Siemens site, at another site, and they had a similar concept, and they were saying around 2 terabytes per day, which was a challenge.
Yeah,
of course.
The problem, the infrastructure from our plant, so it's a lot of data.
Okay, thank you. Then we'll wrap it up there. In case you want to speak with Matthias and Michael afterwards, then feel free to approach them. Thank you once again for that presentation. Thank you.